Section 2.5 is about modeling real-world data using scatter plots. Now when you compare two values, that's called bivariate data. Bi meaning two and variate meaning variables. So you're talking about two variables that you're comparing. When you graph them and you look at their relationship, that's called a scatter plot. Here you see some examples of some scatter plots. When the data goes up and to the right, we say that that data has a positive correlation. It has a positive slope up and to the right, and therefore as the bottom value, as the independent value increases, the dependent value also increases. That's a positive correlation. Well, if the data on the bottom goes up or increases, but the data on the side goes down, we say that that's a negative correlation. Now sometimes you might have a scatter plot that has no correlation at all, but if there is a correlation, it's probably going to be one of these two. Here's an example of housing prices per year, and we're supposed to make a scatter plot of this data. Well, my independent value is the year, so I'm going to make that my x's, and then my dependent value is the price, so I'll make that my y. On the bottom, I'm going to say years since 1990. And that way I can use single digits along the bottom. So we'll make this 0, which means that's actually 1990. So if it's 10 years since 1990, then this last spot is representative of the year 2000. On the side, we'll use price. Because the lowest value is 120-ish and the highest value is 180, it makes sense that each one of these would represent 10, starting at about 110. We need a page break in here, or a line break, to show that that's not a typical interval. And now we'll graph each one of these points. So here's what the scatter plot looks like by graphing this data. We can see that it has a positive correlation. It tends to go upward. And once we see this and we see the relationship between the years and the price, we can then begin to predict some things that may or may not happen in the future. One method we can use to predict things is by using a line of fit. And a line of fit is the line that closely approximates the data. And once you have the data set on a line of fit, you can then create what's called a prediction equation that finds the equation of that line of fit and then predicts things that happen in the future. So we're going to use the data that we've already created, the graph that we've already created, and we're going to make a line of fit for this. Now everyone's line of fit will be a little different, but you want to try to create a line that goes through as many points as possible. You want to try to get points, you don't want to do a line like this that's way above all the points, and you don't want to do a line like this that has every other point above it. You want to try to do one that goes through most of the points. You can include a lot of the data, as much of the data as possible. Here's a line of fit that goes through most of the data. It has a positive slope, and I think it represents the cluster of data pretty well. Now, to write an equation, I need 2 points, and you don't want to pick 2 points that are right next to each other. You certainly don't want to pick the first and the last point here because they're not even close to the line. I like this point here because it's almost on the line, and this one's almost on the line too. They're a decent distance apart, so I'm going to use those 2 points, and they're this one and this one. So we got 1994, which I'm just going to use 4 because it's all 1990s here. So 4, comma 130, and 8 for 1998, comma 152.5. So this is my x and this is my y, this is the year and this is the price. I'm going to use these 2 points because they're close to my line to find my slope. So 152.5, minus 130, so y minus y over x minus x. So 22.5 over 4 is about 5.63. So that's the slope that I'm going to use. My slope should be 5.63. And if you use different points, you're going to get a slope that's a little different than that, but it should be close to the 5.5 range. And even though your equation might be a little off, it should be close to the one that I'm using here. Now I'm going to plug the rest of my information into the point slope form. And I like the first point, so that's the one I'm going to use. Y minus 130 equals my slope 5.63 times x minus 4. I'm going to distribute now and simplify. So 5.63x minus 22.52. I'm going to add 130 to both sides. So my final equation in slope-intercept form is 5.63x plus 107.48. So this equation that you see down here is an equation, a prediction equation that can be used based on that data that I've collected. And now I can use this equation to predict any time. If you wanted to find 20 years after 1990 what the housing market would look like, you put the year in here, you calculate, and it should give you what the housing prices were estimated to be.